Good afternoon, students. Hope you all had your lunch. Today we are going to discuss a very important material property, that is modulus of rigidity. So it is a very important property of a solid material, and it is widely used in a mechanics of solids. So in this discussion we are going to understand what is the modulus of rigidity, its definition, and also its importance in the analysis of solids. And this term is denoted with symbol capital G, and it is also known as shear modulus. This modulus of rigidity is also known as shear modulus. And its SI unit is Newton per meter square. So same as the unit of pressure or the unit of stress. So at the end of this session, so you will be able to understand what is modulus of rigidity, and also if you are provided with two modulus of rigidity value, then you will be able to imagine what kind of solid material it is. So let us understand the term modulus of rigidity with the help of an experiment. So I am trying to explain an experiment here. So from that experiment, so you can understand what is modulus of rigidity. So here I have considered two plates, and in between these two plates we have a rubber block. This is a solid material, and the bottom plate is fixed, and the upper plate is not fixed, and a force F is acting on this. And of course this surface is in perfect contact with the plates, and here we have a contact area. So let us say this contact area is capital A. Let us say this contact area is capital A. So this tangential force, we have a tangential force, or this force is tangential to the upper surface of the rubber block, and we have a contact area A. So there is a shear stress acting on the surface of the rubber block. So how to quantify that? You know the shear stress tau equal to F divided by area. Since this is a solid body, when you apply a tangential force or a shear force, definitely it will undergo a particular deformation. Slowly a deformation starts and it undergo a particular deformation. So we have a particular deformation. And if you increase the force, of course the definite deformation will increase, the particular deformation will increase. So I am going to draw another sketch. There I will show you the deformed shape. So from that we can discuss what is shear strain, and then we will be discussing about the modulus of rigidity. So I will show you the deformed shape in another sketch. Let us say the distance B is the gap between this plate, and A is the deformed length. So for a constant force F, there is a particular value of A. So that is the deformation. Okay, or we can say angle of deformation. Okay, this is this angle. This is the angle of deformation. Okay, so this A is the deformed length and B is the gap between plates. So now let us define the shear strain. Okay, so shear strain is denoted by gamma. Okay, shear strain is denoted by gamma. Okay, shear strain. Okay, that is gamma. So gamma is equal to deformed length divided by the perpendicular length, the gap between this plate. So for a solid, okay, this shear stress is proportional to gamma. The shear stress is proportional to shear strain. Okay, we can write like this. Okay, tau is proportional to gamma. So it means that tau by gamma is a constant. Tau by gamma is a constant, or you can make a proportionality constant here. So that constant is G, where G is tau divided by gamma. Okay, so for any material, if you consider this rubber material, you are increasing the force F. Of course, the shear stress will increase, F by A will increase, and of course, the deformed length will increase, so gamma will increase. So shear stress increases and gamma increases. Okay, so this ratio is always a constant, and that constant is known as modulus of rigidity. So for a given sample of solid, so you have a particular value of modulus of rigidity. Okay, now you can have different kind of solid. Okay, suppose if you consider instead of a rubber block, if you consider a steel block, and if you conduct this experiment, your G value will be different. Okay, so Rahul, can you explain? Okay, for steel material or rubber block, we will get a higher modulus of rigidity. Can you explain that? Okay, very good, very good. For steel material, we have higher modulus of rigidity. What is the reason? Okay, in the case of a steel block, you consider the same force F is acting on that. Okay, then you get the same magnitude of shear stress, but steel is, this deform lesser. Even though your B value is same, the A value is small. So you have a shear strain very small value. Since in the both case, rubber block as well as the steel block, you are considering same F's, you have same tau values, you have same B value, but your A value is small in the case of steel and gamma value is small in that case. And of course, the tau by gamma, you are expecting higher value for the steel block. Okay, so it means that the steel having higher modulus of rigidity as compared to a rubber block. Okay, so the material having higher modulus of rigidity, okay, of course, okay, it is very difficult to deform. Okay, so let us summarize this. Okay, now let us summarize this. Okay, so the material modulus of rigidity, we can say it is the ratio of shear stress to shear strain, and material having higher modulus of rigidity, it is difficult to deform. Thank you.